back to our YouTube channel. So if you are watching us for the first time, this is Community Spiritual Explorer Academy channel. So in today's class, we're going to continue on our topic with the standard form. For today, we're going to talk about addition and subtraction of numbers in standard form. But before we proceed, let's quickly recall what standard form is. In our previous class, we discovered that standard form is a way of expressing a very large number in an easier manner. And when we're talking about standard form, your coefficient, which is your 4 digits, must be less than or equal to 1 and less than what? Than 10. Your first digit, which is your coefficient, should not be more than 10 and should not be less than what? Than 1. Now, let's discuss the addition and subtraction of what? Of numbers in standard form. For in today's lesson as well, we're going to adopt some methods that we're going to use to solve this particular problem. And as well, we're going to also recall the law of indices, which is multiplication and division law of indices. Now let's get started. Now take a look at this first question. We have 3 times 10 raised to the power 2 plus 4 times 10 raised to the power 2. Now if you have a question like this, in which your base and your exponents are the same, you don't need to adjust anything here. Just find the common factor here. And if you take a look at this question here, the common factor here is what? 10 raised to the power 2. Now, for this one now, we're going to use 2 methods to solve this particular question. Let's start with the first method. The first method is to change this number to an ordinary number. You change the number to an ordinary number. Now, how are we going to do about that? You have 3 times. Now, 10 raised to the power 2 means what? That's 100. That is 100 plus 4 times 100 again. Now 3 times 100 will give us what? 300 plus 400. Now let's add up this number. We have 300 plus what? Plus 400. This is going to give us what? 700. Now if you take a look at this answer, you can see that the answer is not a standard form. So what we need to do is to change this number to what? Standard form, in which we have what? The first number as our coefficient, which is less than 10. Recall, to express a number in standard form, we have a, which is your coefficient, to be less than or equal to 1 or less than what? Less than 10. Now this number now is more than 1 and definitely is also what? Less than 10. So we express it in this form. We have our standard form expression, which is what? A times 10 raised to power n, where your a is your coefficient, which should be what? Less than or equal to 1 or less than 10, and your 10 is your base, with your what? With your exponent. Now let's express this particular number here in this what? Standard form. Now to express this, we have 7 times 10 raised to power 2. Why are we having 2? Because we are moving our decimal point 1 and 2. And if you are moving your decimal point to the left, that means your exponent is going to be positive. Your exponent is going to be positive. But if you are moving your decimal point to the right, your exponent is going to be negative. Now in this case now, to express this number back, just multiply 7 by 100. You're still going to get your 700 back. So therefore, our answer is 7 times 10 raised to the power 2. For the second method, we consider the power and the base. Since the power and the base are the same, we have a common factor. So we're going to have 3 plus 4 in bracket times 10 raised to power 2. 3 plus 4, that is, you add up your coefficient, which is the first number we're having here, to times 10 raised to power 2, because we have 10 raised to power 2 in common. We have 7 times 10 raised to power 2. This is your answer. Let's take a look at this second question. If you look at this question now, the base and the exponents of the two numbers given to us are negative. So in this case, they have something in common. To use the first method, we have to change this number here back to an ordinary number. We change the number back to an ordinary number. So we have 5 times 1 over 10 raised to power 4 plus 4 times 1 over 10 raised to power 4. Now, this will be 5 over 10 raised to power 4 is going to give us 10,000 plus 4 over 10,000 again. This expression is what? Addition of fraction. Our LCM here is what? 10,000. Our LCM here is 10,000. So 10,000 and 10,000, that's 1, plus 10,000 and 10,000, that's 1. 1 times 4, that's 4. So we have 9 over 10,000. Now to re-express this back in what? In standard form, we're going to be having 9 times 10 raised to power minus 4. It's going to be our final answer for this. Now, the second method, we have 5 times 10 raised to power minus 4 plus 4 times 10 raised to power what? Minus 4. Now, they have something in common. The base of these two questions are the same. So what we just need to do is to add up the coefficients. So we have 5 plus 4, close bracket, 10 raised to power what? Minus 4. So this is going to give us 9 times 10 raised to power what? Minus 4. So you can see that the answer for the first method is the same as the answer for the second method. So the third question says 7 times 10 raised to power 2 plus 6 times 10 raised to power 3. Now if you take a look at this question now, the base and the exponent are not the same. So all you need to do in this aspect is to adjust the base and the exponent of either of these two values given to us. For the first method, we need to change our number to an ordinary number. So we have 7 times 10 raised to power 2 is 100 plus 6 times 10 raised to power 3 is 1000. So we have it this way. 7 times 100 is 700 plus 6 times 1000 is what? 6,000. So we add up the numbers, so we have 6,000 plus 700. This is 0076. You can see that this number is not in what? Standard form. So recall that your coefficient should be less than or equal to 1 or less than what? Or less than 10. That is, our first digit here should be what? Should be less than or equal to 1 or less than 10. Now to express this in standard form, we're going to be having 6.7 times 10 raised to power what? Let's count. 1, 2, and 3. That is times 10 raised to power what? Power 3. If you are moving to the what? To the left, that will be positive. If you are moving to the right, that will be negative. So we are having 6.7 times 10 raised to power 3. In other words, to get this number back, you have 6.7 times 1000. You're going to have your number back. You need the decimal point 3 times 1, 2, 3. So you're going to be having 6700. You're going to have your number back. So this is our final answer. Now let's use the second method. Looking at this number, they don't have anything in common. The basis and the exponents are different. They don't have anything in common, so the basis and the exponents are different. So all we need to do is to adjust our base to be the same. Now let's change this base and exponent to be the same as the what? As the power of 3. Now let's adjust this now. So to adjust this, we'll be having 0.7 times 10 raised to power 1. Now we're having times 10 raised to power 1 because if I want to get my 7 back, I multiply this 0.7 times 10, give me the 7 back. So we have times 10 raised to power 2 plus 6 times 10 raised to power 3. Now we have 0.7 times. Now we need to apply our multiplication rule in indices. And what does the multiplication rule say? It says that when you're having a base with exponent n times another base with what? Exponent n. They are both having the same basis but different exponents. Your base will be equal to n plus n. So that's what we're going to do here as well. Since they're having the same base, then we are going to have 10 raised to power 1 plus 2 plus 6 times 10 raised to power 3. So we are having 0.7 times 10 raised to power 3 plus 6 times 10 raised to power 3. Now they are both having the same basis now. We can now evaluate completely. So we have 0.7 plus 6 times 10 raised to power 3. Since they are having the same basis, 6.7 times 10 raised to power 3. So this is our answer, and you can see it's the same thing as the first answer we got here. So our answer is also the correct question. The first question says evaluate 1.6 times 10 raised to power minus 2 plus 3.4 times 10 raised to power minus 3. Now let's use the first method. The first method now we need to change this expression to an ordinary number. So let's go. Having 1.6 times 1 over 10 raised to power 2 plus 3.4 times 1 over 10 raised to power 3. So we have 1.6 divided by 10 raised to power 2 means 100 plus 3.4 divided by 10 raised to power 3 means what? 1000. So either way, you can use your addition of fraction, or we go by changing this what 1.6 to express it in what an ordinary number, which will give us 0.016 plus 0.0034. So we have expressed it in what an ordinary number. This is decimal number. So we're going to add up the numbers. So we have 0.016 plus 0.0034. So this will be 4. This is 910.0. So don't forget, this number is not yet in what standard form. So we need to express it in standard form. And I told you, if you are moving our decimal number to the right hand side, we're going to be having what is negative exponent. And if you are moving it to the left hand side, we're going to be having what positive exponent. So let's move this 1, 2. So this will be 1.94 times 10 raised to power minus 2 times 10 raised to power minus 2. So let's solve this same question using another method. So we have 1.6 times 10 raised to power minus 2 plus 3.4 times 10 raised to power what? Minus 3. So don't forget, I told you that to use this second method, all you need to do is to adjust your base with different exponents to be the same. You make the base with different exponents to have the same exponent. So to solve this now, let's adjust our exponent to the minus 2. So we're going to be having 1.6 times 10 raised to power minus 2 plus 0.34 times 10 raised to power 1 times 10 raised to power minus 3. So we have 1.6 times 10 raised to power minus 2 plus 0.34 times 10 raised to power 1 plus minus 3. Now here now we're going to apply our multiplication law in indices. So we're going to have 1.6 times 10 raised to power minus 2 plus 0.34 times 10 raised to power plus 1 plus minus 3 is going to give us what? Minus 2. So now they're having the same basis with different exponents. So now they're having the same basis with different exponents. So in this case now you can see that the two exponents are the same. So we can now evaluate completely. So we have 1.6 plus 0.34 close the bracket times 10 raised to power what? Minus 2. Since that's what we have in common, so we have 1.6 plus 1.6 plus 0.34 times 10 raised to power what? Minus 2. So this will be 491. So therefore, our answer will be 1.94 times 10 raised to power what? Minus 2. You can see that our answer is the same as this one, as the second method. So let's go for the fifth question. The fifth question says evaluate 5 times 10 raised to power 4 plus 2.9 times 10 raised to power 3. Now to use the first method now we need to change our number to an ordinary number. So now let's change this number to an ordinary number and we evaluate completely. So we have 5 times 10 raised to power 4 is what? 10,000 plus 2.9 times 1,000. That's what it is. So this will give us 50,000 plus, to adjust this number to be 29, we're going to be having 29. Don't forget, I told you if you move your decimal number to the back, you're going to be having what? A power of negative. And if you are moving it to the front, we're going to have the power of what? Positive. So this will be 29 times 10 raised to power minus 1 times 1,000. So this can be expressed as 50,000 plus 29 times 1 over 10 times 1,000. Now we can reduce this. So we'll be having 50,000 plus 29 times 100. So this will be 50,000 plus 29 times 100 will give us 2,900. Now let's add up the numbers. So we're going to be having 50,000 plus 2,900. This is 0,0,925. Now, if you take a look at this answer now, it's not taking standard form. So let's convert it back to what the standard form. Don't forget your standard form expression. This for our n. So let's express this in standard form. We have 1, 2, 3, 4. So our final answer will be 5.29 times 10 raised to the power 4. 5.29 times 10 raised to the power 4 is your final answer. So for second method, all we need to do here is to change our base with different exponents to be the same. But for easy calculation, all we need to do is to change our second base to be the same as the first base with different exponents. So we have 5 times 10 raised to the power 4 plus 2.9 times 10 raised to the power 3. So let's adjust this to what? So we're going to be having 5 times 10 raised to the power 4 plus, let's adjust this to 2.9 so that we'll be having what? The power of 4. So we're going to be having 0.29 times 10 raised to the power 1 times 10 raised to the power 3. We have 5 times 10 raised to the power 4 plus 0.29 times 10 raised to the power 1 plus 3. We have applied our multiplication rule. So we're having 5 times 10 raised to the power 4 plus 0.29 times 10 raised to the power 4. Now, so you can see now that they're having the same base with the same exponent now. So now we can evaluate completely. So we are going to be having 5 plus 0.29 close the brackets times 10 raised to the power 4, which is the common factor here. So we're going to be having 5.29 times 10 raised to the power 4, which is the same as the answer we have here. You can see that. Alright. The sixth question says evaluate 8.65 times 10 raised to the power minus 5 plus 5.7 times 10 raised to the power minus 5. Now they are both having the same base with the same exponent. So let's change this expression to an ordinary number. That's for the first method that we have. So to change it to an ordinary number, we're going to have 8.65 times 1 over 10 raised to the power 5 plus 5.7 times 1 over 10 raised to the power 5. So we have 8.65 divided by 10 raised to the power 5 means 100 of 1,000. 100 of 1,000. So we have 5.7 divided by another 100 of 1,000. So you can use addition of fractions to also evaluate. But for easy understanding, let's change each number to decimal number that we had. So to change this back to an ordinary number, we need to move our decimal number. How many times? Move it 5 times. So to express this number in an ordinary number, which is decimal number, we're going to be having 0.0000865 plus, we're having how many zeros? 1, 2, 3, 4, 5. The next one, we're going to be having 0.00057. Now express it in another number. The next thing we need to do is to add up the numbers. So we have 0.0000865 plus 0.00057. So let's add up our numbers. So we have 5. This is 13. Move your 1, 9. Going to be having 14. Move your 1, 1. 0, 0, 0.2. Now to express this in a standard form, don't forget our standard form. A times 10 raised to the power n. So coefficient times 10 raised to the power exponential n. So to express this in standard form, let's move our decimal point 1, 2, 3, 4. This is the first number we are having. So we are having 1.435 times 10 raised to the power minus 4. That's going to be our final answer. Now let's apply our second method to see if we are still going to get the same answer as the first method. So we have 8.65 times 10 raised to the power minus 5 plus 5.7 times 10 raised to the power minus 5. So to apply the second method, we don't need to change any exponent. here. Since they are having the same exponent, all we just need to do is to evaluate completely. So we have 8.65 plus 5.7 times 10 raised to power minus 5, which is the common factor here. So we have 8.65 plus 5.7. This is 5. This is 13.9. This will give us 14 times 10 raised to power what? Minus 5. Now, this number is not a standard form. This 14.35 is not the standard form because the standard form rule says your coefficient should be what? Less than or equal to 1 or less than what? Than 10, and this is more than 10. So all we need to do is to what? Is to reduce this number. So we have 1.435 times 10 raised to power 1 times 10 raised to power what? Minus 5. Because we are moving our decimal point once to the first number given here, which is 1. So, and this will be positive. If you are moving to the left, it will be positive. If you are moving to the right, it will be negative. That's why we have more positive of 1 here. So we have 1.435 times 10 raised to power. We're going to apply our multiplication rule in indices here. So we have 1 plus minus 5. So this will be 1.435 times 10 raised to power minus 4. So let's take a look at this. You can see our answer is also the same as what as the first method.